Let's use this. Let's see how we do. F prime of x equals, the constant multiplier rule says that we can just leave this alone, this constant multiplier here, times the derivative of x squared, which is 2x. We multiply by the power and lower the power by 1, and x to the 1 is just x. 3 times 2 is 6, x. The shorter way to do it is just 2 times 3 is 6, and lower the power by 1, x. Okay. Here, find f prime of x. Hopefully we realize that this is not a power rule right now. We need to rewrite it. To rewrite this, this is 2 times x to the negative 4th. Notice that the 2 doesn't have a negative on it or anything. The 2 is just in the numerator. So 2 times x to the negative 4th. So the derivative is going to be multiply. 2 times negative 4 is negative 8. X to the, we need to lower the power by 1, negative 5. The negative 8 will stay on top over x to the 5th. Okay. This next one, what is the derivative? Well, we know that this can be rewritten as 2 times x to what power? Well, it's a negative power because it was in the denominator, and it's a fraction because it's a root. So 2 times x to the negative 1/2 power is what this one was equal to. It's a negative power because we're dividing, and it's a fraction power because it's a root. Now we can do the derivative because it's a power rule. Negative 1/2 multiplies times 2 to give me negative 1. I'm not going to write the 1 because 1 times anything is itself. And we need to lower the power by 1. So negative 1/2 minus 2/2 is negative 3/2. And last, I need to rewrite this. This is negative 1 over, it's over because it's a negative power, over, over the square root of x cubed. So over the square root of x cubed. Okay. This next one, we need to rewrite. Guys, when we rewrite this, this is 6/4 x to the negative 2. And you can simplify this if you want. This can be simplified. It might make it a little easier, or we can simplify it at the end. I'm going to go ahead and simplify it right now. This is 3/2 x to the negative 2. And so when we multiply 3/2 times negative 2, multiplying and dividing by the same thing cancels out. It's a nice trick. It's 3 times negative 1 is negative 3. The power goes down by 1, x to the negative 3. And so now we can rewrite it as negative 3 over x cubed. Okay. All right, these are actually a little bit easier. These are sums and differences. This happens all the time. Let's do one together real quick. No, you guys can do it. You guys can do it. But let's see how you did. So we multiply by these are sums and differences, so we can just do each one separately. That was our sum and difference rule. It says we can do them separately. The derivative of x cubed is 3x squared, and we can just do separately. What is the derivative of 4x? Remember that the derivative of just an x is 1. The derivative of x is 1, and so 4 times 1 is just 4. And the derivative of 5, remember that the derivative of a constant is 0. And so the derivative is 3x squared minus 4. So these become really easy after a little while, but they are slightly different for some kids. Remember that x to the 1 power, when you multiply it, becomes 1x to the 0 power, which is 1. And so it's important to remember that if there's just an x, it becomes 1. And if there's a constant, it becomes 0. That's our constant rule. Okay, let's see how well you remember these ones from the other day. These need to be memorized. You don't want to have to do a limit definition every time. So f prime of x equals, let's see how you guys did, negative 6x squared plus 18x. The derivative of cosine is negative sine of x. And the derivative of sine of x is cosine of x. So we leave the constant multiplier alone, and we bring it down. Notice that when there is adding a constant, that goes to 0. But if the constant is multiplying, we need to multiply by that constant. Okay, last one, and I think this one should go pretty well for you. You should be starting to get the hang of it. We multiply, 4 times 3 is 12, lower the power by 1. We multiply, 3 times negative 2 is negative 6, lower the power by 1. We multiply, 2 times 5 is 10, lower the power by 1. Now it's x to the 1 power, which is just x, and the derivative of a constant is 0, and so that's not going to be there. Woo! Guys, this is our longest lesson of the year so far. It's also super important. So, like I said, you cannot make up your own rules. You do not get to make up your own rules and be like, I'm going to do the derivatives of parts of these and then multiply them at the end. That's not a thing. It will come out wrong. These are two things that are multiplying. We have not learned a rule for what happens if there are two functions that are multiplying, unless one of them is a constant. If one of them is a constant, you leave the constant alone and do the derivative of the other one. But that does not work for multiplying. There are completely different rules for multiplying and dividing things. And so that's what's up here, guys. I think I'm going to split this into two. Okay. So what we need to do is we need to be able to rewrite it as something we can do. So when you see two functions multiplying, well, you know how to multiply it out. We can just distribute. That's how we can multiply. We can rewrite it. Notice I'm not putting y prime yet. This is not the derivative. I'm just rewriting this in a different way. 2x squared times 3x cubed is 6x to the 5th. 2x squared times negative 2x is negative 4x cubed. Now I'm going to distribute this one. 3x times this is 9x to the 4th. 3x times negative 2x is negative 6x squared. And now I can do the derivative because it's just the sum and difference rule. The sum and difference rule says we can just do them each separately. So we can't do them separately when they're multiplying. You couldn't be like, oh, this is going to be 4x plus 3 times 9x squared minus 2. This is so bad. Don't ever do this. If there are two things multiplying, you can't just do them separately. Only when they're adding and subtracting can you do them separately. But now we can. The derivative, y prime, notice I've switched over from y to y prime now because I'm about to do the power rule, is I multiply 30x to the 4th minus 12x squared, multiply and lower the power, multiply and lower the power, and I'm going to multiply and lower the power. Now there's just an x there. X to the 1 is x. Same idea here. This cannot be done. You can't just like do the derivative of the top divided by the derivative of the bottom. That is not how derivatives work. It would be wrong. We don't have a rule for if there's like g of x over h of x. You cannot do just take the derivative of the top divided by the derivative of the bottom. Don't ever do stuff like that. You don't get to make up your own rules here. The derivative rules get real weird. So you can only stick to the rules you've learned. This is not just a sum and difference. There's this dividing part that's messing it up. But what are we allowed to do? Well, it's dividing by a monomial, and dividing distributes. You guys know from Algebra 1 that if you have like 3x plus 6 divided by 3, you just divide 3x by 3, and you divide 6 by 3. It's the same thing with variables. Hopefully you feel good about this from pre-calculus. 3x cubed divided by x squared, we can rewrite as, so x cubed divided by x squared, the x's cancel out, and we end up getting only one x left over. Here, x squared divided by x squared is just 1, so there aren't any x's left over. And 5 divided by x squared, nothing cancels out. The 5 is still on top, and the x squared is still on the bottom. Here, there were more x's on the top than the bottom, and so we weren't dividing anymore. But here, there were more x's on the bottom, and so we need to be a little careful there. And now this is something we can do because this one can be rewritten as a power rule. We couldn't do a dividing rule on this. We don't know any dividing rules, but we can rewrite this as 5x to the negative 2 power. So I'm just going to rewrite it just like right there so I don't have to rewrite everything. So this is the derivative of x is just 1. The derivative of 2 is 0. And the derivative of 5x to the negative 2, we multiply by the negative 2. So negative 10 x to the, we need to lower the power by 1, negative 3. And I need to rewrite at the end. This is 3 minus 10 divided by x cubed. Okay. Let's do some applications. What are some of the ways derivative questions could come up? Find the slope of the line tangent to 3x squared at x equals 4. Well, the slope of the tangent line should set off alarm bells in your head. The slope of the tangent line is the derivative at whatever point we're looking at. So the slope of remember, the slope of the tangent line is a way of asking for the derivative. What is the slope of the function? That's what the derivative tells us. So this is asking us to find the derivative at x equals 4. The way we find the derivative at x equals 4 is we first find a formula for the derivative at any point. So we find the derivative formula, which is easy. And then we want the derivative at x equals 4. You will notice that instead of putting f prime of 4, I'm now putting f prime of x, I'm putting f prime of 4. This one says this is a formula to find the slope at any x. It'll be 6 times x. This says this is the slope at 4, which is what it was actually asking for. And that is 6 times 4, which is 24. And that is the answer. The slope of the tangent line for 3x squared is 24. It's like super steep by the time you get to x equals 4. The slope is 24. And notice, we could have done this by putting in, let's think about how we did this on the first. I believe you actually had, no, you didn't. It was a function very much like this. You could put in 4 and f of 4, which is 48. You could put in 4.001 and use a calculator to find out. This will be like 48 point, it'll be like 48.024, I don't know, something like that. It comes out to something like that. I'm not doing this as a calculator. I might be wrong, guys. Don't hold me to this, but I bet it comes out to be that. And then you'll do like y2 minus y1, 48.024 minus, oh, this was wrong. It was 02. Why was this? Why did I get, what is this? Oh, this should just be, yeah, that's right. So 48.024 minus 48 over x2 minus x1, and it'll come out to be 0.024 over 0.001, which is 24. And this is so much more work than just looking at it and being like, oh, the derivative formula is 6x, and you plug in 4 and you get 24. Like, this takes so long and this is so fast. I hope you're really enjoying these new skills we have. Find the equation of the tangent line. So always think to yourself, what is the question asking? The equation of the tangent line is asking you to find what equation the tangent line has, and we need the slope and a point at x equals 1. So they've given us the x equals 1. So we've got the 1. We can plug it in to get y1. So that's our point. So 1 comma, when x is 1, 1 squared is 1, 3 divided by 1 is 3. So we've got our point. And now we need the slope. And we'll use our derivative formula. How do we do the derivative of this? Well, this needs to be rewritten as a power rule, 3x to the negative 2. And so y prime will be negative 6x to the negative 3 power. We need to lower the power down by 1. So we multiply and lower the power down by 1. And we rewrite this as negative 6 over x cubed. A negative power means dividing. And now we can just plug in 1. So y prime at 1. So this is a formula for the slopes. This is now the slope at a single point. Y prime of 1 is negative 6 over 1 cubed. 1 times 1 times 1 is 1. And negative 6 over 1 is negative 6. So we're writing the equation of the tangent line. Y equals negative 6 times x minus 1 plus 3. The slope times x minus x1 plus y1. Okay, try this one on your own from start to finish. And hopefully you realize that it's asking you to find the equation of the tangent line. That's y equals the slope times x minus x1 plus y1. What are the things you need to find the equation of the tangent line? Well, you need the derivative will tell you the slopes. That's how we find the slopes. And we need a point. It gave us the x value of the point, and we need to plug it in to find the y value. So 4 cubed, 4 times 4 times 4 is 64. And the square root of 64 is 8. I will tell you, I actually think it's easier to rewrite it as square root of x cubed like this, where you do the square root first and then cube it. The square root of 4 is 2. 2 times 2 times 2 is 8. It's smaller numbers, and these are the same. The 3 can be on the inside or the outside. So I've got my point. Now I need to find my slope. Here I need y prime. And before, I'm going to make a mistake here. You tell me what's wrong here. Y prime equals x to the 3/2 power. What was my mistake? Well, this isn't y prime. This is still just y. I was just rewriting it. I have not used the power rule. I've not lowered the power by 1. I've not multiplied by the power. And so this is just another way of writing the y values. Don't put y prime there. And now when we do the power rule, I'll multiply by 3/2. I need to lower the power by 1. 3/2 minus 2/2 is 1/2. And this is the derivative. Y prime equals, I'm going to make a mistake here and you tell me what it is. Oh man, you guys couldn't see this. The mistake here, I hope we saw, is that this should not be in the denominator. It is not a negative exponent. This should be 3/2 times the square root of x. Okay, so 3/2 times the square root of x, and so y prime at x equals 4 is 3/2 times the square root of 4. Square root of 4 is 2, and 3/2 times 2 will just be 3. Multiplying and dividing by 2 cancel out. And so the slope is 3. So the equation of the tangent line then is y equals 3 times x minus 4 plus 8. Whoo! Okay. Guys, what is something you cannot do here? What are you not allowed to do? You cannot just do the derivative of this times the derivative of this. That is not a thing. There is no rule that says you can do the derivative of two things multiplying. In fact, you don't know a rule for this yet at all. And so since you don't know a rule for two things multiplying, you need to simplify it to a way that you can do it. So this is not f prime of x. I'm just rewriting it. Simplify this, and you should have gotten x cubed plus 4x squared minus x squared minus 4x. And then f prime of, oh, can I combine like terms? Okay, so this is not f prime of x yet, because I'm just going to combine like terms. I'm not doing any derivatives. Plus 3x squared minus 4x. Notice I could have taken the derivative of this one already as I combine these two, but I'm going to do the derivative of all of it at once. And so I want to make sure it's all written in a way I can take the derivative of. So f prime of x equals 3x squared plus 6x minus 4. We multiply by the power, lower the power by 1. Multiply by the power, lower the power by 1. Remember that the derivative of x is just 1. Okay. Ooh, this is a harder question. Find the points, if any, at which the function y equals x cubed plus x has a horizontal tangent line. So there's some function, and they want to know where it has a horizontal tangent line. This comes up on the AP exam fairly often. What does it mean for a function to have a horizontal tangent line? Well, what we know about horizontal tangent lines is that the slope is 0. And the slope we find by finding f prime of x. And so it's saying that the f prime of x needs to equal 0. That's not x equals 0 that we plug into f prime of x. It's saying we take the derivative and find where it's equal to 0. So this is the equation for some cubic, and we want to find where its slope is 0, where it will have a horizontal tangent line. So we're going to find the slope. What is the derivative? Well, y prime equals 3x squared plus 1. The derivative of x is 1. And this slope needs to be 0. This is setting up an equation to solve. Where is the slope going to be equal to 0? Where will the slope be horizontal? And we can solve this from algebra 1 or algebra 2. We get x by itself. So we're going to say subtract 1, divide by 3, x squared equals negative 1/3. We take the square root. And we should notice something here. We are doing the square root of a negative. This is imaginary. And so let's answer the question. Find the points where x cubed plus x has a horizontal tangent line. And the answer is there are none. There are no real x values that have a horizontal tangent line for this function, because when we did the slope formula, the slope is never equal to 0. So tricky. All right, here is a new skill. Look look at this closely. What's different about this? You may notice it has f prime prime of x. This is the second derivative. We'll talk more about what the second derivative means later, but it just means you do the derivative twice. It's the derivative of the derivative. You just do the derivative twice. It's the slope of the slopes, which is weird. So the way we do it is we just find the derivative first, just like normal. So what is the derivative of this? 12x cubed. We multiply and lower the power. We multiply and lower the power. This is 0. And we do the derivative of sine of x. The derivative of sine of x is cosine of x. And then, that's the first derivative. We find the slope of the slope. We find the slope of this function. And that's the derivative again. So multiply by the power, lower the power by 1. Multiply by the power, lower by the power by 1. Remember, the derivative of x is just 1. And the derivative of cosine of x you need to have memorized. The derivative of cosine is negative sine of x. And that is it here, guys. Those are a bunch of things we've learned. I hope you have a good time practicing on your homework, and have a good rest of your day.